In problem number 9, we need to calculate the derivative of the function f of x equals e to the power x squared plus 3x minus 4x plus 1 squared. We need to calculate the value of the derivative of this function at x equals to 0. So the function consists of two terms. The first term is an exponential term, e to the power x squared plus 3x, and the second term is a polynomial term, 4x plus 1 raised to the second power. Both of these terms are convenient to differentiate using the chain rule. So let me briefly review the chain rule. Suppose we start, chain rule is a differentiation rule that tells us how to make a substitution in a formula for a derivative of some function. So suppose we start with the derivative of some function f of x. So derivative of f of x, and let's say we know what this derivative is. I'll write f prime of x for that derivative. Now suppose we want to make a substitution and we want to substitute or plug in, instead of x, something else, and that something else could be an expression in terms of possibly a new variable, t, u, v, y, or it can even be an expression in terms of the same variable x. So maybe I should not write x equals to, but what if we want to substitute, what if we want to replace x with some other expression in terms of x, which I will call g of x, some other function of g of x. So the chain rule says that it's not enough to just go ahead and replace x everywhere you see x in the formula with whatever you want to replace x with, as you would, for example, in some algebra formula. But fortunately, there is a small correction that is sufficient to give us the correct result for a new derivative. So let's go ahead and first of all replace x with whatever we want to replace it with. So the formula is going to become f of g of x prime, the derivative of this result, derivative of the function that results from replacing x with g of x in the function f of x. It will equal to f prime of g of x. So I'm basically, everywhere I see x, I'm replacing it with g of x. And if we just do this, it's very easy to see that we're not going to get a correct answer. And to get the correct answer, the right-hand side has to be multiplied by the derivative of the function that we're replacing x with. So in other words, it has to be multiplied by g prime of x. And so this formula is called the chain rule. Let me give you an example with this chain rule, and which will also illustrate the need for this chain rule. So let's start with a function f of x equals to x squared. Now by the power rule, we know that the derivative of x squared equals to 2x. Now suppose I want to replace x with x squared. Now I'm not suggesting that x equals to x squared. Rather I suggest that we make the substitution, and sometimes we may want to do that. So in algebra, if you have a formula that is an identity that is always true, you could make any substitution for any of the variables that are part of that formula, and you will get another identity that will always be true. It doesn't work this way for derivatives. So if I go ahead and I look at this formula, which is a correct formula for the derivative of x squared, the derivative of x squared equals to 2x. If I go ahead and I replace, everywhere I see x, I replace x with x squared, the resulting formula will be incorrect. Let's see that. So I'm going to get x squared all squared the derivative of that equals 2 times x squared. That's what I would get if I were just replacing x with x squared in the formula for the derivative of x squared in this formula. But this result is incorrect because on the left hand side, x squared squared is x to the 4th. And so the left hand side now is the derivative of x to the 4th. And then on the right hand side we have 2x squared. So this formula would suggest that the derivative of x to the 4th is equal to 2x squared. But that is incorrect because, again, by the power rule, we know that the derivative of x to the 4th is 4x cubed. So what is it that we're missing? The chain rule tells us exactly what we're missing. The chain rule says that in order to get a correct formula for a derivative of a new function that you get by substituting instead of x something else in the original function, you need to go ahead and do the substitution in the formula for the derivative of the original function, but then on the right hand side of that formula you need to multiply by the derivative of what you're replacing x with. So in this case you need to be multiplying by the derivative of x squared, which is 2x, and so then the formula becomes the derivative of x to the 4th equals 2x squared multiplied by 2x, and that of course is 4x cubed. And now that gives us the correct result for the derivative of x to the 4th. Okay. So this is the chain rule, and this is what we will need to calculate the derivative of the function that's given to us. Our first term is the exponential term. Of course, by the difference rule, the derivative of our function will be the derivative of the first term, of the exponential term, minus the derivative of the polynomial term of the second term. And now let's talk about the derivative of the exponential term. Let's talk about this derivative. So for this derivative, the starting point is the fact that we learn about exponential functions, namely that the derivative of the natural exponential function with the base e, is equal to itself. Maybe a little bit surprising, but this is a remarkable property of the natural exponential function, that its derivative is equal to itself. Now, why this is relevant to us is because we need to differentiate the similar function where instead of x, the exponent is now not x, the exponent in our function is different. It's x squared plus 3x. So basically what we need to do is we need to make a substitution. We need to replace the x in e to the power x. We need to replace that with x squared plus 3x. And so we'll be making a substitution, and that's why we will need to use the chain rule. So let's go ahead and make that substitution. I will be replacing x with x squared plus 3x in this formula right here, which says that the derivative of e to the power x equals to the itself e to the power x. Okay, so according to the chain rule, we in order to get the correct derivative of the modified function, which is our exponential term that we're interested in, we need to go ahead and make the substitution. Everywhere we'll look at the formula for e to the power x, its derivative, and everywhere we see x, we're going to replace it with x squared plus 3x. It's going to give us this, e to the power x squared plus 3x. But now we need to multiply this by the derivative of what we are replacing x with. In other words, we need to multiply this by the derivative of x squared plus 3x, but this derivative is easy to calculate by the power rule. And so what we're going to get is, I'm going to write the derivative of x squared plus 3x first. It's 2x plus 3 times e to the power x squared plus 3x. Okay, great. So this is the derivative of the exponential term. And now let's calculate the derivative of the polynomial term, and then we'll just subtract the two to get the derivative of our function. Now, the polynomial term that we need to differentiate is 4x plus 1 squared. Now, one way to calculate this derivative would be to expand the square. Just write 4x plus 1 times 4x plus 1, multiply everything out, and then differentiate term by term using the power rule. But since I just explained to you the chain rule, let me go ahead and use the chain rule to calculate this derivative faster. So our function is a function where something is being squared. So in order to calculate this derivative of 4x plus 1 squared, why don't we look first at the derivative of x squared? Now, the derivative of x squared is equal to 2x. And this is the power rule. And now, in order to calculate the derivative of 4x plus 1 squared, we need to start with the formula for the derivative of x squared, and then make a substitution, replace x with 4x plus 1. Let's go ahead and do that. So we will get, according to the chain rule, we will get that the derivative of 4x plus 1 squared equals 2 times 4x plus 1. And so that's, I'm finished with replacing x with 4x plus 1 in this formula. And now I need to multiply the result by the derivative of what we're replacing x with. And that is just 4x plus 1. And so what that gives us, it gives us 2 times 4x plus 1 times 4. Altogether, this gives us 8 times 8x plus 1. If you like, you can distribute 8 to the two terms in parentheses, but it's not going to be really that important for us here. And a very good exercise is to calculate the derivative of 4x plus 1 squared in a different way, in the first way that I indicated earlier, by first expanding 4x plus 1 squared and then differentiating term by term, and then compare the results of these two different ways of calculating the derivative and just confirm that they are indeed exactly the same. Okay, so now we can return back to our function. I've calculated the derivative of both terms. And let me just write the result. I think I have a little bit of space here. So f prime of x will be equal to 2x plus 3 times e to the power x squared plus 3x minus 8 times 4x plus 1. So all that remains at this point for us to do is substitute instead of x0, because if you remember, the problem was asking to calculate the value of this derivative at x equals to 0. And so just plug it in and calculate. So we get 2 times 0 plus 3 times e to the power 0 squared plus 3 times 0 minus 8 times 4 times 0 plus 1. Now, for the exponential term, we get e raised to the power 0. That gives us 1. And all of this simplifies to 3 times 1 minus 8 times 1. So 3 minus 8, negative 5. This is our final answer for the value of the derivative of this function at x equals to 0.